Hey everyone, and welcome back for another deep dive. We're going to be using a physiological psychology textbook today, along with some really cool diagrams and images
Yeah.
to explore how our brains make and understand language.
It's a very remarkable system.
It
Yeah.
is. So, what should we do first? Where should we start this journey into the brain's language centers?
Well, let's start with the story of Mr. S.
Okay.
It's a story that I think really highlights just how delicate and intricate our language systems can be.
Okay.
So imagine waking up one day and you suddenly can't understand any words spoken to you.
Oh gosh.
It's as if everyone around you is speaking a completely foreign language.
Yeah.
This is what happened to Mr. S after he experienced some brain damage.
Wow, that must have been terrifying for him.
It was.
Yeah. To be surrounded by the sounds of language but not be able to grasp the meaning.
Exactly.
It makes you realize how much we take language for granted.
We do.
Yeah. I
Absolutely.
mean, it's so essential to the human experience.
It is. Yeah, and as tragic as it is, Mr. S's case offered scientists valuable insights. It pointed to the idea that different parts of the brain have specialized in different aspects of language.
Oh,
And for most people, it's the left side of the brain that really takes the lead when it comes to language processing.
oh, so brain lateralization.
Exactly.
So like the left side is the logical analytical one,
Yeah.
and then the right side is like the creative artist.
Yeah, that's a good way to think about it.
Okay.
And about 90% of right-handed people have left hemisphere language dominance.
Okay.
But it's also true for the majority of left-handed people, too.
Oh, really?
Yeah, about 72%.
So even lefties, those supposed rebels of the brain,
Yeah.
usually rely on the left side for language.
Yeah, they do.
That's pretty surprising.
Yeah,
But okay, so we talked about these specialized areas.
right.
So what exactly is going on in that left hemisphere that allows us to form words into meaningful sentences?
Well, there's a region in the frontal lobe called Broca's area, and it plays a critical role in speech production.
Okay.
You can think of it as the architect of spoken language.
Okay.
It's taking all those thoughts and ideas you have and turning them into coherent sentences.
Oh, so it's kind of like the construction crew of language,
Yeah.
putting all the pieces together in the right order.
Exactly.
What happens if there's damage to that area?
Well, damage to Broca's area can lead to Broca's aphasia.
Okay.
And imagine knowing exactly what you want to say,
Right.
but struggling to get the words out in a smooth and grammatical way.
Oh, gosh.
Your speech becomes very halting and telegraphic,
Yeah.
almost like you're trying to send a really complex message with a limited number of words.
That must be so frustrating
It is.
to have those thoughts locked inside and unable to express them.
Absolutely.
Yeah. Are there different levels of severity with Broca's aphasia?
Yeah, it definitely varies in severity.
Okay.
Some people may only have mild word-finding difficulty,
Okay.
and others may struggle to even produce single words. But the good news is that with therapy and support, a lot of people with Broca's aphasia see significant improvement in their communication abilities over time.
Oh, that's great.
It really highlights the brain's amazing capacity for adaptation and rewiring.
It is amazing how resilient the brain is.
Yeah,
But we've been focusing a lot on Broca's area
right,
and its role in speech production.
right.
What about understanding the language that we hear?
Yeah.
What part of the brain is in charge of that?
That's where Wernicke's area comes in,
Okay.
and that's located in the temporal lobe.
Okay.
It's the language comprehension center.
Okay.
So if Broca's area is the architect, Wernicke's is the interpreter,
Okay.
making sense of the words we hear and connecting them to meaning.
So it's like having a translator in your head,
Exact.
turning those streams of sounds into coherent ideas.
Yeah.
I bet damage to Wernicke's area leads to a whole different set of challenges.
Oh, it does.
Yeah.
Damage to Wernicke's area results in Wernicke's aphasia, and it presents a stark contrast to Broca's aphasia.
Okay.
So while individuals with Broca's aphasia struggle to produce speech, those with Wernicke's can speak fluently and with ease.
Okay.
But the problem is their speech is filled with nonsensical words and phrases lacking any real meaning.
Oh, wow.
Yeah, so it's like their internal dictionary got all scrambled.
Yeah.
Yeah, they can form words and sentences,
Right.
but the words don't carry a coherent message.
That's fascinating and heartbreaking at the same
It
time.
is.
Yeah, because I imagine it's incredibly confusing for both the person with Wernicke's aphasia
Yeah,
and the people that they're trying to communicate with
it is.
to not be able to understand each other.
Yeah, it really highlights how crucial that connection between words and meaning is. Yeah, to effective communication.
For sure.
And to give you an example, The textbook mentions a case where a man with Wernicke's aphasia was asked about how he got hurt.
Right.
And his response was a long, rambling story full of made-up words and phrases that had absolutely no connection to the question
Oh my God.
or to reality.
That's a really powerful example of how disruptive this can be.
It is.
Yeah. And it makes you appreciate how much we rely on shared understanding and coherent language to navigate the world.
We do.
Yeah.
Absolutely.
So it's not just about those two areas, though, right?
No,
Broca's and Wernicke's.
they're part of a larger network,
Okay.
connected by these neural pathways that allow information to flow back and forth. Think of it like a complex transportation system with highways and byways connecting different parts of a city.
Okay, so how do these language areas talk to each other?
Well, one of the key players in this communication network is a bundle of nerve fiber called the arcuate fasciculus.
Okay.
So you can think of it as a superhighway connecting Broca's area in the frontal lobe to Wernicke's area in the temporal lobe.
Oh, so that's like the information highway of language,
Exactly.
allowing the messages to travel between understanding and speaking.
Exactly.
What happens if there's a roadblock on that highway?
Well, if the arcuate fasciculus is damaged, it can lead to a condition called conduction aphasia.
Oh.
And people with this condition have a very specific deficit.
Oh,
They
no.
struggle to repeat words or phrases, even though they understand what the words mean and they can speak fluently.
So they can like explain the concept of a banana, but when you ask them to say banana, they can't do it.
That's a good way to put it.
Oh, that's so strange.
It
It
is.
seems like such a peculiar disconnect.
It is. It's
Yeah.
like the message gets all garbled in the transmission between understanding and speaking.
Yeah.
It demonstrates that even a simple task like repeating a word involves multiple steps
Right.
and intricate coordination between different brain areas.
Okay, we've been talking a lot about spoken language,
Right.
but what about the written word?
Yeah.
I mean, reading and writing seem so fundamentally connected to spoken language.
They are.
Yeah. Does the brain handle written language in a completely different way?
It's a great question. While reading and writing involve additional brain areas related to visual processing,
Okay.
they are very closely tied to the same neural networks that process spoken language.
Okay.
So often difficulties with spoken language like aphasia have a direct impact on reading and writing abilities.
So if you have trouble understanding spoken words, you're likely to have trouble with reading as well.
Exactly.
Oh, interesting.
It's like the brain uses a similar set of tools, whether we're decoding spoken or written language.
Okay.
And damage to certain pathways can disrupt our ability to read and write, often in ways that mirror the types of aphasia we see with spoken language.
Okay.
For instance, let's consider a condition called pure alexia.
Okay.
Imagine being able to write perfectly well, but being completely unable to read anything, even what you just wrote.
Wait, you can write, but you can't read anything.
Yeah.
Wow.
Yeah, so it's as if written language has become a foreign code.
Yeah.
You can produce the symbols, but you can't make sense of them anymore.
That's wild.
It is. And pure alexia often results from damage to a pathway that connects the visual cortex,
Okay.
which is responsible for processing what we see,
Right.
to the language areas in the left hemisphere.
Yeah.
And the corpus callosum, which is that bridge of fibers connecting the two halves of the brain,
Right.
plays a very crucial role here.
So it's like the visual information from the written word gets stuck.
Yeah,
It can't cross over to the language processing centers.
that's a good way to put it.
That makes sense.
Yeah.
But then it raises the question, how does the brain assign meaning to those visual symbols, whether they're spoken or written?
You've hit upon a fundamental question in the study of language and the brain.
Right.
What is meaning, and how is it represented in this really intricate network of neurons?
Yeah, that's a huge question.
Yeah.
Is there like a dictionary in our brains?
Not quite.
Okay.
But think of meaning as being distributed across a network of interconnected neurons called cell assemblies.
Cell assemblies.
Yeah.
Okay, so I'm imagining little groups of neurons, each one specializing in a particular concept or word.
Yeah.
So when I think about pizza, a specific group of neurons lights up.
That's the general idea.
Okay, and then a different set lights up if I think about democracy or quantum physics.
It's like each word or concept has its own neural signature.
Okay.
And here's the amazing part.
Okay.
These cell assemblies aren't static.
Right.
They're constantly changing and adapting based on our experiences and learning.
Oh, so the more I think about pizza, the stronger those connections get.
Exactly.
And it's easier for my brain to access that delicious concept.
Exactly.
Yeah.
And it's not just within a single cell assembly.
Right.
These assemblies can link up with others, forming even larger networks.
Oh, wow.
So it allows us to connect ideas, build complex understandings, and make associations.
So like my pizza cell assembly might be connected to my cheese assembly and my Friday night assembly and my best friend assembly if we always have pizza together.
Precisely.
Wow.
It's like building this intricate web of associations. Yeah.
And it beautifully illustrates how distributed meaning is in the brain.
Okay.
There's no single pizza neuron.
Right.
It's all about patterns of activation across this vast network of cell assemblies.
So cool.
And this distributed nature of meaning explains why damage to different areas of the brain can lead to very specific types of language deficits.
Okay.
Like the inability to name objects or actions or even abstract concepts.
This is blowing my mind.
It's amazing, isn't it?
It's like a giant interconnected network of meaning just constantly buzzing with activity and making connections.
It is.
And speaking of making connections, let's talk about a condition that seems to disrupt this web of meaning.
Okay.
Anomia.
Anomia.
Yes.
It's a fascinating condition that provides a window into how we store and retrieve information about the meaning of words.
Okay.
And it's the word-finding difficulty we were discussing earlier.
Right.
Remember the woman who couldn't name a fence,
Yes.
but could perfectly describe its function and appearance? Yes, it's like having a word stuck on the tip of your tongue, but like on a much larger scale.
Exactly.
Yeah, you know what you want to say.
Right.
You understand the concept,
Yeah.
but the word just escapes you.
Exactly. And what makes anomia so intriguing is that it can occur with damage to different parts of the brain.
Oh, really?
Yeah.
Wow.
So it suggests that different aspects of meaning might be stored in different locations.
Interesting.
Some people with anomia struggle with naming objects. Others have more trouble with actions, and still others find it difficult to come up with the words for abstract concepts.
So maybe different categories of words have their own designated neighborhoods in the brain.
Well, it's not quite that simple, but research does suggest that different categories of semantic knowledge might be organized in different parts of the brain.
Okay.
For example, brain imaging studies have shown that different areas light up when people are asked to name pictures of animals versus tools.
So there's evidence for this category specificity
Yeah.
in how our brains store meaning.
Yeah.
That's so cool.
It's like the brain has its own filing system for words.
Right.
Makes it more efficient at retrieving the information we need.
But how does that filing system get built in the first place?
Yeah.
How does the developing brain learn to connect those sounds and symbols to their meaning?
Yeah.
How do we go from babbling babies to eloquent speakers?
That is a great question.
Yeah.
And it's one that continues to fascinate researchers.
Right.
How do we acquire language?
Yeah.
How do our brains make sense of this complex system of symbols and rules?
Right. And we've been talking about the typical brain,
Right.
but there's a whole spectrum of neurodiversity.
Exactly.
And
right.
sometimes language development takes a different path, and we see things like autism or dyslexia.
Exactly.
So how do those differences in brain structure and function
Yeah.
influence how people learn and use language?
That's a huge question.
Yeah.
And incredibly important.
A very important question.
Yeah. And, we've been focusing on the typical brain
Right.
and how it handles language. But understanding how these individual differences in brain structure and function can influence language development is a crucial area of ongoing research.
Research that has the potential to improve the lives of millions.
Absolutely.
Yeah. I can't wait to see what breakthroughs the future holds.
Me too.
But for now, I think we've given our listeners plenty to ponder.
Yeah, I think so.
Yeah.
We have. It's a journey of lifelong learning.
Speaking of lifelong learning, you mentioned that our brains are constantly adapting and rewiring
Right.
based on our experiences.
Yeah.
I'm curious, how does that actually work?
Well, it comes down to these amazing little communication hubs in our brain,
Okay.
neurons.
Neurons.
Yeah, they're constantly forming new connections and strengthening existing ones through a process called synaptic plasticity.
Synaptic plasticity.
Yeah.
It sounds so complex.
It is, but it's really cool.
Okay, so our synapses, those tiny gaps between neurons,
Right.
are actually changing based on what we learn
Correctly.
and experience.
It's like this constant dance of connection and reorganization.
Wow.
Yeah, happening within our brains. And one of the key principles behind this dance is something called the Hebb rule.
The Hebb rule. Okay.
Neurons that fire together wire together.
Oh, I like that.
It's catchy.
It is catchy.
Yeah.
And it makes sense.
Yeah.
So if two neurons are activated together frequently, The connection gets stronger.
Exactly.
Almost like they're forming a tighter bond.
Exactly. The more those neurons fire together, the more ingrained that connection becomes,
Okay.
making it easier for information to flow between them.
So, like, if I start learning a new language,
Right.
as I practice those new words and grammatical structures,
Yeah,
the neural connections get stronger and more efficient.
exactly.
You got it. It's like my brain is building a new highway for that language.
Exactly. And this applies to all sorts of learning,
Yep.
not just language. Every new skill you acquire, every fact you memorize, every experience you have is shaping and reshaping those neural connections in your brain.
Yeah, that's incredible.
Yep.
It makes you realize that learning is a physical process,
It is.
changing the structure of our brains.
It is.
Wow. And so it's not just about strengthening those existing connections.
Right.
Our brains can actually form brand new connections throughout our lives.
Absolutely.
Wow.
The brain is remarkably plastic,
Okay.
meaning it can rewire itself and form new pathways.
So our brains are never fixed.
No, they're not.
That's encouraging.
Yeah.
We have the power to keep learning and adapting no matter our age.
Exactly. And this ability to form new connections is particularly important when it comes to things like recovering from a brain injury or a stroke.
Okay.
Remember Mr. S?
Yes, the man who couldn't understand spoken words.
Exactly. Now, he sadly never fully regained his language abilities.
Right.
But a lot of individuals with brain damage see significant improvement
Okay.
through therapy and rehabilitation.
Okay.
And this is possible because the brain can actually rewire itself,
Wow.
creating new pathways to bypass those damaged areas and restore function.
So even when there's damage, the brain can find workarounds,
Exactly.
rerouting those information highways
Exactly.
to restore communication.
It's amazing.
That's really remarkable.
It is.
So it really speaks to the importance of therapy and support
It does.
for people who've had strokes or brain injuries.
Absolutely.
Okay, we've been talking about Broca's area
Right.
and Wernicke's area
Yeah.
and how those are hubs for speech production and comprehension.
Right.
And we've talked about cell assemblies
Yeah.
and synaptic plasticity.
Yeah.
But are there other brain regions that play a role in language processing?
Oh, absolutely.
Okay,
Language doesn't exist in isolation.
right.
It's deeply interconnected with a wide range of cognitive processes.
Like what?
Well, things like attention, memory, executive function.
Okay, so it's not just those specific language areas.
Right.
It's the whole brain working together as a team.
Exactly.
So, for example, if you're having trouble focusing, could that affect how well you understand a conversation?
Absolutely. Attention plays a crucial role in filtering out distractions.
Right.
And allowing us to focus on the relevant linguistic information.
Okay.
So if your attentional systems are compromised,
Mhm.
it can make it much harder to follow a conversation or to process written text.
It's like trying to listen to a podcast while juggling chainsaws.
Oh.
That's a great analogy.
You're not going to get the full picture.
You're not.
Yeah. Okay, so attention is important.
Very important.
What about memory?
Memory is also essential.
Okay.
Think about all the vocabulary you've accumulated,
Right.
all the grammar rules you've internalized,
Yeah.
the countless stories and conversations you've stored in your memory.
We draw on our memories to make sense of new information.
Exactly.
Yeah, to predict what someone's going to say next.
Yeah.
To understand humor.
Absolutely. It's sarcasm.
It's like language is built on this foundation of shared memories and experiences.
So what happens if there's damage to the brain areas involved in memory?
Well, it can definitely affect language abilities.
Oh.
In fact, there's a condition called transcortical sensory aphasia.
Transcortical sensory aphasia.
Yes.
Okay.
That provides a really striking example of this.
Okay.
People with this condition have difficulty comprehending spoken language and producing meaningful speech.
Okay. So that's similar to Wernicke's aphasia.
It's similar,
Yeah.
but there's a key difference.
Okay. What is it?
People with transcortical sensory aphasia can repeat words and phrases accurately even though they don't understand what they're saying.
Oh, so they can like parrot it back,
Exactly.
but it's meaningless to them?
It's like a meaningless string of sounds to them.
Wow. So what's going on in the brain that causes this disconnect?
It's thought to be caused by damage to the pathways that connect Wernicke's area to other parts of the brain's association cortex.
Okay. So the areas that help us make sense of the world.
Exactly. So
Okay.
Wernicke's area, the language comprehension center,
Right.
is still receiving that auditory input,
Okay.
but it can't connect to the broader network of knowledge and meaning.
So it's like having a dictionary, but no encyclopedia.
That's a brilliant way to put it.
You can look up the words, but you don't know how they fit into the big picture.
Exactly. It highlights how crucial those connections between different brain areas are
Right.
for creating coherent understanding and meaningful communication. And it speaks to the incredible complexity of language processing.
Yeah.
It's not just about those specialized language centers,
Right.
but it's this symphony of activity across the entire brain.
This is mind-blowing.
It is amazing.
It's amazing to think about all this neural machinery working behind the scenes.
Yeah.
Every time we have a conversation, read a book, send a text message.
Every thought we form.
Wow.
It's a testament to the brain's amazing ability to integrate all this information from these multiple sources
Right.
and to create meaning from these random sounds and symbols
Yeah.
and to connect us to each other through the power of language.
Okay, so we've explored how all these brain regions work together
Right.
to make and comprehend language. We've seen how damage to specific areas can disrupt this system,
Yeah.
leading to all sorts of fascinating language disorders.
It's fascinating.
And we've even touched upon how language is connected to other things like
Sure.
attention and memory.
Absolutely.
Okay, but I want to talk about another fascinating part of language,
Okay.
the bilingual brain.
Bilingualism.
Yes.
It's a remarkable phenomenon
Yeah.
that reveals just how flexible and adaptable the human brain can be.
Okay.
For a long time, scientists debated whether bilingual individuals stored information about their two languages in completely separate brain regions.
Oh, so like they have two dictionaries in their head.
Exactly.
That makes sense.
It does.
Yeah, because it seems like such a hard task
Yeah.
to juggle two sets of vocabulary and grammar and all those
Yeah.
cultural nuances.
But research actually suggests that the brain is much more efficient than that.
Really?
Yeah.
Wow.
While there's still some debate about the precise organization, the current understanding is that bilingual individuals store information about both languages within the same brain regions,
Okay.
with varying degrees of overlap depending on factors like age of acquisition and proficiency.
So if you learn both languages as a kid,
Right.
the neural representations might be more intertwined
Exactly.
than if you pick up a language later in life.
Exactly. It's like those neural pathways are woven together during those early years
Yes.
of brain development.
Interesting.
And brain imaging studies have shown that bilinguals activate similar brain regions when processing both of their languages,
Okay.
with some subtle differences depending on the task and the languages involved.
So the bilingual brain isn't working twice as hard.
Right.
It's more like it's become a master juggler,
Yeah.
switching back and forth
Exactly.
while using a lot of the same neural circuits.
Exactly.
That's really efficient.
It is. And research suggests that this juggling act can actually provide cognitive benefits.
Oh, like what?
Well, it can enhance things like executive function, attentional control, and even multitasking abilities.
So being bilingual was like a brain workout.
You could say that.
You're strengthening those cognitive muscles and keeping your brain sharp.
Exactly. And this idea of cognitive benefits extends beyond just bilingualism.
Okay.
Researchers are finding that engaging in any activity that challenges your brain,
Right.
whether it's learning a new language
Right.
or playing a musical instrument or solving puzzles,
Okay.
can help maintain cognitive function and protect against age-related decline.
So the key to a healthy brain is to keep it active and engaged,
Absolutely.
always learning new things.
Use it or lose it. That
Exactly.
applies to our brains just as much as our bodies.
I like, okay, we've talked about bilingualism, but I want to shift gears
Okay.
and talk about a condition called pure word deafness.
Pure word deafness. It's a fascinating condition, and I imagine incredibly disorienting.
Yeah.
Imagine being able to hear sounds just fine,
Okay.
like music or traffic or birds chirping,
Right.
but being completely unable to understand any spoken words.
Oh my God.
It's as if everyone around you is speaking a language that you've never heard before, just meaningless sounds.
That sounds so isolating.
It is.
To be surrounded by language but not understand it.
Yeah, it would be like watching a foreign film with no subtitles.
Exactly.
And it really highlights the distinct neural pathways involved in processing spoken versus written language.
So how does this happen?
Well, pure word deafness occurs when there's damage to a very specific pathway that connects the auditory cortex,
Okay.
which processes sounds to Wernicke's area.
Our language comprehension center.
Exactly.
So the sound information is reaching the brain,
Right.
but it can't get to the part that decodes the meaning.
It can't get to Wernicke's.
Okay.
It's like having a working radio, but a break-in speaker.
Oh, okay.
Yeah, the signal's coming through, but you can't hear it.
Okay.
And here's what's really interesting. People with pure word deafness can often read and write without difficulty.
They can. So they can process language visually, but not through sound.
That's exactly right.
Yeah.
It's like their brains have found this workaround,
Wow.
relying on the visual system to access language.
That's amazing.
It's a striking example of how the brain can adapt and compensate when faced with challenges.
It really speaks to the plasticity of the brain.
It does.
This deep dive has been incredible.
It has.
We've explored the workings of all these different brain regions,
Yeah.
learned about neural connections,
Yeah.
bilingualism,
Yeah.
pure word deafness. It's amazing, isn't it?
It is. It's just amazing to think about how much is happening in our brains.
Yeah.
Every time we speak, listen, read, think about words.
We've only just scratched the surface.
There's so much to learn.
There is.
Okay, one last question.
Okay.
We've seen how damage can disrupt language.
Right.
But what about when the brain is structured differently from the start?
Yeah.
How does that impact language development?
That is a huge question.
Yeah.
An incredibly important one.
You know, we've been focusing on the typical brain
Right.
and how it handles language.
Yeah.
But there's a whole spectrum of neurodiversity out there, and understanding how those individual differences in brain structure and function can influence language development is a really crucial area of ongoing research.
Research that has the potential to help so many people.
Absolutely it does.
I can't wait to see what the future holds.
Me too. It's a really exciting field
Yeah.
to be working in.
Yeah. I think we've given our listener plenty to ponder.
Yeah, I think we have.
Yeah.
Yeah.
Yeah, it really is humbling to think about how much we're still learning about the brain
It is.
and how those discoveries can help us understand people who learn and think differently.
Absolutely. It's a field that's constantly evolving,
Right.
with new insights emerging all the time.
Yeah. And I've been thinking a lot about a condition we talked about earlier,
Yeah.
conduction aphasia,
Okay.
the one where people have trouble repeating words,
Right.
even though they understand what they mean, and they can speak fluently.
Right.
What I found fascinating is that it comes from damage to that bundle of nerve fibers connecting Broca's and Wernicke's.
The arcuate fasciculus.
Yes, the arcuate fasciculus.
Yeah, it really highlights the importance of that smooth communication between different brain regions.
Yep.
You know, you can understand the words, you know what you want to say,
Right.
but the message gets garbled somewhere between those two areas.
It's like having a great composer and a virtuoso musician, but there's no conductor to coordinate the whole thing.
That's a great analogy.
So the music might have all the right notes,
Right.
but it doesn't come together as a symphony.
Yeah, it really underscores the complexity of language processing.
Yeah.
It's not just about having those specialized areas for speech production and comprehension.
Right.
It's about the interplay between them, the flow of information back and forth, the
Yeah.
constant coordination and integration.
Yeah, it makes you appreciate all those moving parts,
It does.
all that neural machinery that's working behind the scenes.
Yeah, every conversation, every utterance,
Every thought.
every internal monologue even.
And this complexity is even more apparent when we consider how much language varies
Oh, yeah.
across different cultures.
Absolutely.
Our brains aren't pre-programmed with some universal language decoder.
Right.
The way we process language depends on the specific features of the language we're exposed to.
Exactly.
So the sounds, the grammar, the nuances of meaning.
Each language has its own unique fingerprint,
Yeah.
its own set of rules and patterns that our brains have to learn and adapt to.
So do you think that learning a new language could change the physical structure of your brain?
I think it does.
Yeah.
Research suggests that it does.
Create new pathways and connections?
Yeah.
Rewire those circuits?
That's exactly what research suggests.
That's so cool.
Yeah. Studies have shown that learning a new language, especially in early childhood, can lead to measurable changes in brain structure and function.
Wow.
Yeah. It can increase gray matter volume in certain language-related areas, strengthen the connections between those areas, and even enhance activity in regions involved in attention and executive control.
So being bilingual is like a brain boost.
It is.
Yeah.
It's not just about learning new words and grammar.
Right.
It's about expanding your cognitive horizons
Yeah.
and enhancing your brain's flexibility and processing power.
I like that. And it's not just limited to language,
No, it's not.
right? Learning any new skill
I mean, a new skill.
can do the same thing.
It can.
You have a huge impact on the brain.
Huge. Yeah.
Yeah, like learning to play an instrument,
Right.
learning a new sport,
Absolutely.
even learning to code.
It all promotes neuroplasticity and cognitive resilience.
Our brains are amazing.
They are.
They're constantly changing and adapting.
Throughout our lives, yeah.
We really have the power to shape our own brains
We do.
through the things we do and learn.
Through the experiences we choose and the challenges we embrace.
Yeah, well said. I think we've given our listeners a lot to think about today. A whole new perspective on language.
Yeah.
All that activity going on in our brains every time we use language.
It's been a really fascinating journey exploring the world of language and the brain.
It has.
And I hope it inspires our listeners to keep learning and exploring and marveling at this incredible organ.
And remember, the brain is like a muscle.
It is.
The more you use it,
The stronger it gets.
so keep those synapses firing.
Stay curious.
Never stop exploring.
Until next time, happy learning.